So today we're going to continue with absolute value equations. And before we start with the new idea today, I just want to drive home what we learned the other day, which is absolute value means distance, and distance can't be negative. And so what that means is whatever is inside absolute value signs, whatever is in here can't be negative. So this could be two possible values, right? Whatever's in there could be 7 or it could be -7, right? Because if you have the absolute value of 7, that's equal to 7, but the absolute value of -7 is also equal to 7. So there's always two possibilities. It doesn't matter what's in there. So now let's plop something in there, right? So let's call this m plus 3. So we want to know the absolute value of m plus 3 equals 7. But again, m plus 3 could be 7 or it could be -7, because either way the absolute value of that is going to end up with 7. So because of that, we need to write two equations, right? And the first equation is if it's equal to 7. So we're saying m plus 3 equals 7, and we're trying to figure out what value of m makes that true. But the other option is that m plus 3 equals -7. So again, really quick, just driving this home, we have two equations because there's two possible values that this quantity in here could have. So we just have to solve for these two now, right? So I'm going to solve by subtracting 3 on both sides, and I get m equals 4, and that's one possibility. And on the other one, I subtract 3, and I get m equals -10, and that's the other possibility. If we plug either of those in to the equation, we're going to get 7. We'll just plug in 1 just to show you. So let's take -10. So absolute value of -10 plus 3. Okay, we want to know what is that? Well, -10 plus 3 is -7, and the absolute value of -7 is 7. And so sure enough, that works. And the same would be true if you plugged in 4. Okay, so now let's take that idea and let's work it on something a little bit new, which is what we're doing today. So what we're doing today is this. We have our absolute value quantity, but now we're multiplying it by 3. And the key takeaway is that the absolute value signs have nothing to do with this 3. There's no bearing on the 3. So what we need to do first is get the absolute value quantity, this amount alone, get that separate. Anything else, anything that's not inside the absolute value quantity, we need to get rid of that first. And so we're going to do that in this case by dividing both sides by 3, because that'll cancel that out. But we do it to both sides, of course. And so notice we end up with just that absolute value quantity on the one side, and 15 divided by 3 is 5. But we've isolated that now, right? We've isolated this, which is our goal. Once we do that, this problem looks just like this problem, which means this value in here, right, this whole thing, could either be 5 or it could be -5. It has to be one of those two values, because either of those two values, if you take the absolute value, you'll end up with 5. So we're going to set our two equations just like we did in the other one. So we know that 13 minus 2x might be 5, or 13 minus 2x might be -5. And we're going to be a little squeezed for space, but we'll make it happen. So anyway, I am going to subtract the 13 from both sides. So -13 minus 13, and I get my -2x. Don't forget the signs, right? -2x equals -13, and 5 is -8. And so now I need to divide by the -2, right? Divide by -2, divide by -2. And x equals negative divided by negative is a positive. 8 divided by 2 is 4. So x is 4 is one possibility. And down here, same thing, -13. And the reason I'm subtracting 13 is because I want the x's, I want the term with the x's alone on the one side of the equation. I need to isolate that. So anyway, the 13's are gone. I have my -2x. Don't forget that negative. Don't forget the sign. -5 and -13 is -18. Same steps, right? I'm dividing by -2, divided by -2, and I get x equals +9. Okay, and so those are your two possibilities. But remember, the key part in this problem was actually up in the beginning, which was this. If you see something that's not inside the absolute value signs, get rid of it. Isolate the absolute value quantity on one side of the equation, and then it's just like the ones we were doing the other day. So just a couple more, and then we're done. And again, I see a bunch of things here. I see the 4 and a -7 that's not there. So I'm going to just treat this as like an x or something, right? I'm going to just take this whole thing. I want to just get everything else out of there. So just like we would in any other problem, I'll add 7, right, to both sides. I will get 4 times the absolute value of b minus 1 equals 17 plus 7 is 24. So just do that. Okay, again, I got to get rid of that 4, so I'm going to divide by 4 on both sides. That's gone. And I have my absolute value quantity. The absolute value would be minus 1. And 24 divided by 4 is 6. Okay, but look what we have right here now. We have the absolute value quantity all alone, which is exactly what we want. It's alone. It's isolated on one side of the equation. And remember, this now might be equal to 6, but it could also be equal to negative 6. So we need to write our two equations at this point. So b minus 1 might be equal to 6, but b minus 1 might also be equal to negative 6. And we just got to solve for both of those. So add 1 to both sides. B could be 7, or if we add 1 to both sides over here, b could be negative 5. And those are your two answers, two possible solutions. All right, let's do one more example. Same thing. I see some stuff, right? I'm trying to isolate this, amount. I got to get rid of the 4, got to get rid of the negative 2 because they're not inside the absolute value quantity. So let's do that. I am going to start by adding 2 plus 2 to both sides, right? So I have 4 times the absolute value of 2k plus 3. But I have gotten rid of that 2, and then so 6 plus 2 is 8. Now, I got to get rid of the 4, and that's 4 times that amount. So I'm going to divide by 4 on both sides. So that's gone. And so you get absolute value of 2k plus 3 is 8 divided by 4 is 2. So now we still have two possible answers, right? This amount could either be equal to 2 or negative 2. So we need to write an equation for each possibility. So what if 2k plus 3 equals 2? What value of k will make that true? And what if 2k plus 3 equals negative 2? What value of k will make that true? So let's just figure that out. So let's subtract 3 from both sides. 2k is equal to negative 1. Divide by 2, right? And you get k equals negative 1/2. And there's nothing wrong with fractions. All right, over here, same steps. Notice we're doing the same steps on both sides because you have the same equation. You just have a different possible solution. So we're still going to have 2k equals negative 2 minus 3 minus 5. Same thing, divide by 2, divide by 2. And you get k equals negative, you could say negative 5/2, or that's really negative 2.5. So you could make that, get rid of that. And there you go. Okay, so just remember the key step is, in the beginning, getting rid of anything that's not inside the absolute value quantity. And by get rid of, I mean get it over to the other side. Get rid of it, right? How do you get rid of a minus 2? You add 2. How do you get rid of times 4? You divide by 4. Just remember to do it to both sides. Then, once you get the absolute value quantity alone on one side, then it's just like the problems we were doing the other day. You just set your two equations because this amount could be 2, but it also could be negative 2. So you need two equations.